Yeah, once again, we are meeting before our TASMO competition is commencing. Yeah, in this Thursday. So 2 days before the competition starts, hopefully everyone is faring well with their preparation. All right. So let's wait until 7:15 for the live stream to start promptly. All right. Today we will be going through some common knowledge points and mistakes in common Math Olympiad competitions. Okay, and after that, I will also give a final briefing on the TASMO competition, what you should take note of, what you should bring, and absolutely how to come to the venue, yeah, what's the correct timing, etc. All right, so let's wait for around 2 more minutes and then we will start at 7:15 sharp. Okay, so 1 more minute before we finally start. Okay, today is 2 days before our TASMO competition for P1. So hopefully everyone is almost ready for the competition by now. I will be sharing more about some knowledge points and also some things to remember, okay, for the TASMO competition. Okay, so let's wait for around 1 more minute and then we will start our live stream. Okay, in the meantime, get your water ready. Okay, hydrate yourself and then we will start. All right, it's 7:15. Hello, everybody. Welcome to today's final live stream before our TASMO for P1. I'm Teacher Yong Lam, and today I will bring you through some common knowledge points and also common mistakes, okay, in this live stream that will last for 1 hour. All right, hopefully everyone is ready and you have done the extra questions I've given you last Friday. And without further ado, let's get started. Today, I will go through some knowledge points from different modules such as geometry, data processing, word problems, logical reasoning, and finally, number theory. All right, and at the end, very important, I will be giving some key reminders for TASMO 2024. So let me put a triple star here. Okay, do stay tuned to the end to find out what you should remember, what you should prepare, what you should bring for this competition. Okay, and without further ado, let's get started with our first knowledge point, which is on nets of cubes. So a lot of me, hey, Teacher Yonglam, if I see nets of cubes, how should I do this? Right, this appeared in a lot of our sample papers. I also gave some extra exercises on this that has a smiley face. Okay, then I need to make sure the cube also has a smiley face, or the other way around. If my cube has a smiley face, but my net doesn't have a smiley face, then I know that that net is wrong. Okay, make sure all the faces that appear on the cube also appear on the net. Okay, so that is one way to think about it. All right, the second thing is opposite or adjacent faces. Okay, today I would like to share more about how to find opposite or adjacent faces in your nets of cube. So first of all, there are two ways to find opposite faces when given a net of a cube. The first one is what we call an I shape. So when we have three faces lining up next to each other, then the first face on the far left and the last face on the far right, the two of them will be opposite faces. So this actually looks like an eye, right? I have the pupil in the middle, eye white at the side. So these two faces at the side, when you fold them up, you will realize that they are opposite faces. So that is the first way to find out opposite faces in the nets of cubes. Does anyone know what's the second way? Okay, what is the second shape to use to find out the opposite faces? It's a letter, something like z, 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 or something like that. Okay, it's my Z shape. All right, Z shape has four faces and it goes z, z, z. like this. Okay, I repeat, right? So whenever I see this is a Z shape, the two faces at the end, they will be opposite faces. Okay, as you can see over here, when I try to fold them up, actually this face will come over here. Okay, it will come over here, and therefore it forms opposite faces together with the other side. Okay, so these are the two ways to find opposite faces. So you can take a look at the net. Are these two faces opposite or adjacent? If they should be opposite, but they appear adjacent in the cube, then you know, oh, this is an option I should not choose. This is a cube that cannot be formed from the net. Okay, so this is the second way. Third way is on the direction or orientation of the pattern. So when you see things like arrows, certain faces, etc., make sure that these arrows are pointing to the correct direction, or these patterns are pointing to the correct direction. Okay, and last but not least, whenever you see faces in nets that are not together, you can actually make them together by using rotation. So actually, what do I mean? Let's take a look at the sample question I've given you on Friday. All right, which of the following cubes can be formed from this net? Okay, any answers in the chat? Okay, so we see 4 cubes over here. Only one of them can be created using this net. Okay, how are we going to use the techniques just now to find out which cube can be made from this net? Let's check one by one. Okay, starting from A. In A, we have 4, 1, and 5. And these three faces, they are all adjacent to each other. 4 is adjacent to 1, 1 to 5, 4 to 5. Okay. However, let's take a look at where 1, 4, and 5 are at. Okay, 1 is here, 4 is here, 5 is here in the net. Okay, and what do you notice about 1 and 4? Okay, between 1 and 4, what shape do you notice? Okay, I see a 子子子. Draw better. 子子子. So 1 and 4, they are two ends of my Z shape, which means what? Which means 1 and 4 should be adjacent or opposite faces. What do you think? If I see a Z shape, the two ends must be opposite, right? So since they are opposite faces, can they appear next to each other? They are opposite to each other. Can they appear next to each other? That's a no. Okay, so they should not appear together. All right, so A is definitely not a cube that we can form. All right, what about B? What about B? Let's take a look. B, we have 1, 5, and 6. Can I find 1, 5, and 6 together? We have 1 here, 5 over here, and 6 over here. Oh, I see 6 and 5 together. Let's take out this part of my net with 6, 4, and 5. Okay, seems like they are connected together. Okay, if 6 and 5, they are aligned like this, and they share this side with 4, then when I try to fold these 3 faces to form part of a cube, don't you think that 6 will be on the top, 5 will be at the side, and 4 will be at the front? Right, my 6, when I fold this part of the net, 6 will be seen on top, 5 will be on the side, and then 1 will be at the, 4 will be at the front. Okay, so let's check whether this applies to B. In B, we have 6 on the top, 5 on the side, and 1 at the front. Does it match? It doesn't match, right? So since it doesn't match, of course, we cannot form this cube using this net. So B is definitely wrong as well. We are left with C and D. How about C? Let's take a look. In C, we have 2, 3, and 4 together. Okay, we have 2, 3, and 4 together. Are they together in the net? Indeed, they are together, right? I have 2, 3, 4 together. Well, should I choose C straight away since I see 2, 3, and 4 together? Maybe not. You remember I say we also need to check the orientation and direction of the patterns. Okay, so in this part of the net, 3 is on the left, 4 is on the right. But in the cube, 4 is on the left, 3 is on the right. So what should I do? Maybe I should rotate this face, okay, or these faces of the net to form this part. So let's take a look. After rotation, so you see it kind of matches, but look closely. In my net, my 3 dots in this yellow face go from top right to bottom left. Okay? But then in my cube, where is my 3 dots? It's from the top left to the bottom right, right? So you will see that the orientation is different, the direction is different, okay, between the net and the cube. So can C be my answer? C cannot be my answer, so C is wrong. Okay, finally, we have D over here. Okay, 1, 3, and 6. We see 1, 3, 6. But they are not together. How can they be adjacent to each other? Well, in order to shift the faces in the net, I'm going to show you how we can use rotation to shift these faces. Okay, so between 1 and 3, we want 1 to be next to 3, right? So now 1 is sort of a corner away, okay, from 3. So I'm going to rotate face with 1 on it, rotate this face up so that it now becomes next to my face with a 3 in it. So if I want to move this face up, I rotate it. Okay, what should I do? I rotate it clockwise. Okay, and after I rotate it clockwise, it's still one dot in the center, so nothing much. Okay, and why do I rotate clockwise like this? It's because when I fold my net, okay, this side or this edge on the left will coincide with this side or this edge above. Okay, so that's why when I fold them, these two faces, or rather these two edges, will be next to each other. Okay, this is why I need to do the rotation. So I now made 1 next to 3. How about 6? Okay, I'm going to turn 6 to be next to 3 as well. This is by rotating it 1 time. This time it's counterclockwise. Okay, and then I'm going to rotate it. Okay, and once I rotate it counterclockwise for a quarter of a circle, will the 6 dots become vertically aligned or horizontally aligned? It will now be horizontally aligned. Right, so since it's now horizontally aligned, and then after the rotation, I get this part as well. Okay. But then, if I try to rotate it again, I will get this orientation. Does this match the orientation with the net? Let's take a look. Okay, in the cube, 3 is from the top left to bottom right. In the net, 3 is top left to bottom right. For the 6, in the cube, they are vertical. In the net, it is also vertical. So also 1 is on the top. So we can see that the orientation of the patterns are correct. So D is a cube that can be formed from the net. Okay, so I spent a lot of time going through this with y'all because this is something that a lot of students have struggled at. Okay, whenever you see nets of cubes, we do matching. Remember to check not only whether faces are adjacent or opposite, but also check carefully the direction of the patterns. If you need to shift the faces in the net, make sure to use rotation. Is about our geometry module. Let's move on to data processing. This will be a very classic one. We are starting with counting 2D shapes, okay? We will see complex diagrams involving rectangles, squares, triangles, and we want to show how to count these 2D shapes. So my advice to you is to count in order from top to bottom, from left to right. So for example, when I am calculating how many rectangles are there in this figure, I don't jump here and there. I don't say, oh, there's one rectangle here on the top. Oh, there's one at the bottom. Oh, there's one at the left. Oh, there's one at the bottom. No, we do it following the order from left to right, from top to bottom. And also, we need to consider all the possible number of 2 or more rectangles can form a bigger rectangle. All right. So if you have done this question, feel free to tell me what is the number of chat below. Okay, so you might think of 5, 6, 7, done, 7 rectangles. Is that correct? Okay, hopefully by now you realize that I don't only look at these small rectangles to count the number of rectangles. Okay, there are some bigger rectangles hidden as well, and we need to find all of them. Okay, starting with just now, we have 1 rectangle. Okay, how A, we have B, we have C, we have D, we have E, we have F, we have G. Okay, so there are 7 small rectangles. So this trick I use is to label each part with a letter and then just note down which letters will form a shape that we want, triangles or rectangles. In this case, each of the 7 parts is a rectangle itself. All right, so we just note down, using 1 rectangle only or 1 part only, we get 7 rectangles. But don't stop there, okay? A, B, C, D, E, F, G, they are rectangles themselves. But we can combine some of them to form bigger rectangles. So let's take a look. How about if we combine two of the small rectangles to make a larger rectangle? Can we do that? Well, yes, we can, okay? So let's take a look. A, can I combine A with another rectangle to form a bigger rectangle? Definitely, okay, A and C, if I draw it like this, you will see that A and C combine to form a larger rectangle. So A and C form another larger rectangle. Any other rectangles that can be formed with two parts? Okay, for example, C can form it with B. So B, C. Any other parts? Okay, if you have any other combinations, feel free to let me know in the chat below. Okay, can C form rectangles with other rectangles? C and D. Yes, I have C and D over here. Where else? Can C form with some other rectangle? Okay, C and E. Okay, C and E. Where else? Let's not stop here. There are still more below. Okay, E and F. Okay, E and F together forms another, okay, rectangle. And finally, F and G, the two horizontal rectangles, they form a larger rectangle. 6. So we have 1, 2, 3, 4, 5, 6, 6 rectangles, okay, forming using two parts. Shall we stop here? Can we just stop here and say, okay, we are done? Don't, okay? Consider even more parts, okay? What if I use 3 parts instead? Can I form more? Whoa, 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 whoa. Can I form more rectangles by using 3 parts? Let's see. If I start with A, where else can I do? A, okay, A, C, and E. It's 3 rectangle, right? Any other such rectangles? Well, I see B, C, D, 3 in a row, they form a larger rectangle. So that's another case. Finally, we have C, E, and F. So they will also form a larger rectangle. Okay, C, E, F. So there are 1, 2, 3. 3 bigger rectangles formed using 3 parts. All right. Finally, okay, how about 4 rectangles? 4 parts. Okay, we have A, C, E, and F. These 4 parts together, A, C, E, F, they will form a long rectangle. Okay, so we found one more rectangle in this way. And is there any rectangles formed using 5 or more parts? We need to consider all of them as well. But there's none, okay? At most, I can see 4 in a row to form a rectangle. So altogether, we will have 7 plus 6 plus 3 plus 1 equals to 17 rectangles in total. So my answer is 17. All right, so remember, when count them in order and consider all the possible number of parts. Don't just stop at 1 part or 2 parts. Consider, what if I have more parts? Can I find bigger rectangles, bigger triangles? All right, so that's on counting 2D shapes. With 2D, definitely there is 3D. Okay, so our next topic is on counting cubes. This is very commonly seen in lower primary math competitions, so pay attention, all right? I will share with you 2 ways to find the number of cubes, okay? And my advice to you is still to count everything in order, okay? But in what order? We can actually count column by column, okay, from short to tall, from shorter columns to taller columns, or count row by row from top to bottom. So if I want to count column by column, what should I do? I treat each column like a tower, okay? Hopefully you have been to a tower before. There are shorter towers, there are taller towers. Okay, so we want to find the short towers first, and then we go step by step upwards. All right, so in this structure below, where are my column by column towers? So you see there are some shorter towers, right? We start from the shorter towers. So there is 1 cube in this tower. This is the shortest we can find. So we label a 1 on the roof. Okay, on the roof of this tower, label how many cubes are there. Can I find another similar tower? Yeah, there are 2 over here, so 1, 1, label them on top. After we are done with those shorter towers, move on to the taller ones, okay? We have 2 in this column and another 2 in this column, okay? After we find out, in total, all the towers have how many cubes respectively? Add them up, okay? So in total, there are 7 cubes. Here's the first way, okay? The second way you can count cubes is to count row by row. So we start from the top row or the top layer all the way to the bottom layer. Okay, so let's take a look at the top layer first. How many cubes are there in the top layer? Oh, there are two. Okay, two cubes. Yes, the column method is also called the bald man method. Very good. Okay, so row by row, this is the lazy worker method. Okay, but we just count row by row starting from the top. In the top, I have two cubes. Then we move on to the bottom row. In the bottom row, I see one, two, three new cubes. But don't forget, okay, the cubes on top are not floating. There must be some cubes below to support it. Okay, so on top there are two cubes. So in the bottom layer, there should also be another two cubes to support the cubes on top. So there are two cubes supporting those on top and three new cubes that we can see the head of. All right, so in total, there will be 5 cubes. And with that, after finding the number of cubes in each level or each layer, we just add them together. So again, we find 7 cubes. All right, so hopefully these two ways are useful for you to count the number of cubes. Let's see how we can use them to find the number of cubes in this figure below. I will first use the column method, okay? Whenever I want to count column by column, I look for the shortest tower first. Look for the shortest towers first, everybody. We start from below. So look, in this tower, very short. How many cubes are there in this layer? How many are there? There is 1 cube in this layer. Okay, so we label 1 on the roof of this tower or on this bald man. Okay, are there similar short towers? There's 1 here, 1 here, 1 here, 1 here, 1 here. So in total, there are 6 ones. So 6 times 1 is equal to 6. Okay, after labeling all the bottom layer or the shorter towers, we move 1 step up. Are there any tools that we can label? Just right, just nice. 1 on the left, 1 on the right. There are 2 towers with 2 cubes tall. So 2 towers with 2 cubes tall, that gives me 4 cubes. Okay, how about the 3 cubes tall towers? Where are they? Okay, how many are there? There are 1, 2, 3, 4. 4 of the towers with 3 layers, that gives me 12 cubes in total. Okay, but finally, we can still go higher, right? We have 2 cubes with, or rather 2 towers with 4 cubes each. 2 towers with 4 cubes each. So 4, rather 2 times 4, 2 towers, 4 cubes each. That gives me 8. Okay, so these are the number of cubes in towers of different heights. What should we do at the end? We just add them together. So we have 8 plus 12 plus 4 plus 6 equals to 30 cubes. So this is how we can get 30 cubes at the end. All right, that's the first way of counting the cubes. The second way, the second way, okay, is to use the row by row method. So let me quickly do the workings. Okay, in the row by row method, we start from the top row. Okay, in the top row, how many cubes are there here? There are 2 cubes. Okay, then we go 1 level below. Okay, in the 1 level below, how many new cubes with the heads you can find? Okay, there's 1, 2, 3, 4. 4 new cubes. Okay, but don't forget, the cubes on top are not floating by itself. There are certain cubes below that are supporting it. So there are actually 2 more cubes to support the 2 cubes on top. So in total, this layer should have 6 cubes. Okay, moving 1 more layer down, okay, how many new cubes can we see? We see 1 cube, 2 cubes with the heads exposed. So 2 new cubes. But also don't forget to count how many cubes we need to support the above layer. So that's above we have 6 cubes. So in below we also have 6 cubes. Okay, and this will be 8 cubes in total for this layer. Finally, we are at the most bottom level. Okay, how many new cubes can you see? I see 1, 2, 3, 4, 5, 6. That's exactly how many 1 tall towers are there. So 6 new cubes. Don't forget to add an 8, the number of cubes at the bottom we need to support the part on top. So in total, this layer will have 14 cubes. So if we add all these numbers together, okay, you will also get 30 cubes as your answer. So here I provided 2 ways to count cubes. Okay, you can use one way, your favorite way to count, and then use the other way to just check your answer, just to be extra sure. Okay, so 2 ways, all right, hopefully they are useful for you. And now we are done with data processing. Let's move on to one module that I feel is very important. They are my word problems, okay? When it comes to word problems, please read the question carefully and underline any keywords you find. Okay, underline your keywords, read it carefully, okay? Everywhere can be information, so make sure you read the question carefully. In particular, I want to go through queuing problems. Okay, now in queuing problems, usually there are a lot of people behind, people in front, people in between. So we want to draw a picture to help solve the problem. Okay, and take note, there are two types of information. The first type is on cardinal numbers. Okay, cardinal numbers is the usual numbers you use to count. 1, 2, 3. Okay, if I see cardinal numbers like this, I will count the number of people excluding the main character. All right. Okay, and then how about ordinal numbers? Okay, for ordinal numbers, such as first, second, third, when you count, you want to include the main character. Okay, for example, I am the third in the queue. Then the 3 people includes me. I am the third person. All right, so after understanding the difference between cardinal numbers and ordinal numbers, okay, for 1, 2, 3 people, count excluding the main character. For first, second, third, count including the main character. Okay, so with that, let's take a look at our queuing problem. So Pip and Bud are queuing up in front of a food stall with no customers between them. So nobody is between them. Okay, counting from the front, Pip is the 7th customer. From the front, Pip is the 7th customer. Okay, and then there are also 9 people behind, but how many people are in the queue altogether? Now, here's the catch. For this question, there are some people in front, some people behind. But there's actually 2 cases to this problem, okay? What are the 2 cases, you might ask? First case, case 1. Okay, what if Pip is in front of Bud? Okay, this case, I see the answers. Okay, what if Pip is in front of Bud? Okay, but we also have case 2. Case 2, what if Bud is in front? Okay, I didn't mention in the question who is in front, who is behind. So actually both are possible, right? Bud can be in front of Pip. Pip can be in front of Bud. Okay, so let's look through each case one by one. In the first case, Pip is in front. So let's label, okay, a certain direction as the front. For example, let me see. Let's say the left side is the front. Pip, okay, is in front of Bud. All right, and now there are no customers between them, so they are together. Counting from the front, Pip is the 7th customer. Pip is the 7th customer. That means the 7 people includes Pip. So how many people are actually in front of Pip in this case? There are 6 people because we have to count 1, 2, 3, 4, 5, 6, 7. If we want to count Pip as the 7th person, there should be 6 people in front of Pip. Okay, so 6 people in front of Pip. How about Bud? There are also 9 people behind, but 9, okay, cardinal numbers. Cardinal number don't include the main character. That means we really draw 9 people behind Bud. Okay, so I draw 9 people behind Bud. Okay, and then how many people are there in the queue altogether? I want to find in total how many people are there. Okay, so is it 6 plus 9? Don't forget, okay? P and B, they are also people in the queue. So we need to count 2 of them together as well. Okay, so 6 people in front, 9 people behind, including P and B, 2 of them. There are how many people? There are 6 plus 2 plus 9, 17 people. Okay, but that's for the first case, you know. Just now, we said that there are 2 cases. When Pip is in front of Bud, I have 17 people in the queue. Now comes the question. What if, in the second case, Bud is in front? Okay, if Bud is in front, then how do we solve this question? Now, this is slightly trickier, but it's the same concept. Okay, let's say that I have my front over here, and in the queue, Bud is in front of Pip. Okay, this is also possible. The question didn't mention that, so that's another case. Okay, but usually in competitions, they will mention Pip and Bud, who is in the front, who is at the back. All right, now Bud is in front there, and Pip is at the back. Counting from the front, Pip is the 7th customer. So counting from the front again, Pip is the 7th person, which means the person in front, Bud, will be the 6th person. Person number 6 from the front of the queue. Which means, how many people should be in front of Bud? I have the 6th person over here. No, the answer is not 17. Okay, 6 people, or rather, Bud is the 6th person, person number 6. So in the front, there should be 1, 2, 3, 4, 5. 5 people in front of but. So that I have person number 1, 2, 3, 4, 5, 6. Pip is the 7th person. Okay, so up till now, I have found 7 people. But don't forget, there are also 9 people behind Bud. So Bud is over here. I want to put 9 people behind her. There's already 1 person behind. So how many more should be behind Bud? 9 minus 1. Already 1 person here. 9 minus 1 is equal to 8. So I should put 1, 2, 3, 4, 5, 6, 7, 8. I have 8. Okay, over here. All right. So in total, how many people are there? There will be 7 plus 8 equals 15 people. Answer 15 people here. Okay, so this is slightly tricky, mainly because Pete is the 7th customer from the front. Doesn't mean we need to add 6 people in front because Bud is also in front of Pete. So Bud is part of the 6 people. And there are 9 people behind Bud. This means 9 people should be behind Bud, right? But Pip is already behind Bud. Pip is one of the 9 people. So besides Pip, there should be another 8 people behind Bud. All right, so that we have 1, 2, 3, 4, 5, 6, 7, 8, 9 people behind Bud. All right, so overall, this is how we do this question. We just find out how many people are in front, how many people are behind, how many people are in the middle. Okay, and with that, that is how we do our queuing problems. Okay, so this is the first word problem I would like to share. I also have the second word problem, which is on bar models. So hopefully you all have heard about this, but if not, this model is commonly used in shifting to equality questions, one that you have seen a lot in your TASMO sample papers, and also some difference and multiple. So when we want to draw bar models, there are actually a few steps that you need to follow, okay? First step, find out who you are comparing and write down the characters. Are you comparing between teacher and student, between chickens and rabbits, apples and pears, or etc.? So you need to write down the characters. Usually, somebody you have will have more, somebody will have less. So you need to label them down as well. Okay? So assume someone has more, someone has less. Next, we want to draw out our starting line. Okay? Draw a starting line, straight line, to make sure when I draw the bars, they all start from the same point. Okay, next, when we want to draw the bars, when you see someone with more, draw a longer bar for that person. If you see someone with fewer, draw a shorter bar for that person. Okay, so next, you will see that some parts, the more person has, the less person also has. Some parts, the more person has, the less person doesn't have. Okay, with this, we need to label down the information. Some common information to label include my sum, which is everything in total, and my difference. And before you label your difference, make sure to draw a dotted line, okay, to separate between the same part and the difference part. Okay, then we use the brackets to label the difference. Okay, if you know this, very good. Okay, hopefully you can use this well when you see questions like this. So these are the 4 main steps to draw bar models. Okay, and sometimes there might be more than 2 characters, there might be 3, might be 4, might be 5. So you need to be extra careful in figuring out how to draw the model, who has more, who has less, how to compare the differences between 2 parties. All right, so with that, let's take a look at this question. We want to split 88 eggs into 2 baskets so that one basket has 26 more eggs than the other. So how many eggs are there in each basket? So what information can you find in the question? What are the keywords I should highlight? First, any numbers can be good information. We want to split 88 eggs into 2 baskets. So this 88 eggs is the number of eggs we have in total. So 88 is my total, or it is my sum. Okay, add together, I have 88 eggs. This is my sum. Okay, how about the other basket? Or rather the other information, okay? One basket has 26 more eggs than the other. 26 more eggs. So this 26 more, I have 26 more than you. 26 is our difference, right? I have 26 more than you. I have 26. You don't have that 26. This is the difference. And we want to find out how many eggs are there in each basket. So how should we do this? We see sum, we see difference. Someone has more, someone has less. Let's draw out our bar model. Okay, so we are comparing between two baskets, right? So when you label the characters, you can say basket 1 and basket 2. Okay, and let's say basket 1 has more eggs, whereas basket 2 has less eggs. Okay, this is totally up to you, whichever you want to do. Okay, basket 1 has more eggs, basket 2 has less eggs. Okay, before you draw your bars, make sure to draw a starting line first. Okay, so that you know how to find the starting point for the bars. They should start at the same starting point. Okay, so just like we assumed basket 1 has more eggs, so we put a longer bar, okay, for the basket 1 and shorter bar for basket 2. So basket 1 has more, basket 2 has less. But what's the difference? What's the sum? You need to label them, okay? So we can label the sum by combining everything together. There are 88 eggs in total. And we can also label the difference. There will be 26 eggs as the difference. So can you tell me how many eggs are there in each basket? Just now I see someone typed it in the chat. Very good. Okay, can y'all show me your answers again? What is the number of eggs in each basket? Okay, so let's proceed. How do we find the number of eggs in each basket? We know that there are 26 eggs here. How about these two parts? Do we know the number of eggs in each of them? No, we don't. But we realize that this part I label with a triangle is the same as the part below. These two represent the same number. They are the same length, so they represent the same number. This is why I told you to draw the dotted line to separate the difference part from the same part. Okay, so altogether, 88 contains two triangles and one 26. So we have triangle plus 26. Two triangles, 126. Added together gets 88. Okay, so what is the value of two triangles? I just do 88 minus 26 equals 62. Okay, two triangles add up to 62 and make sure the two triangles are referring to the same number. So I see someone in the chat giving me an answer. Very good. One triangle is 31. Okay, that's 62 divided by 2, 31. All right, and with that, we can find out basket 1 has how many? Basket 2 has how many? Okay, for basket 1, how many eggs are there? Is it only 31? Hey, I have one triangle here, but also 26 extra eggs. So for basket 1, I should have 31 plus 26 equals to 57 eggs. All right, and how about basket 2? Wow, I see a lot of answers in the chat. That's right. Basket 2 has only one triangle. So basket 2, I can confirm 31 eggs. Okay, so altogether, I found out basket 1 has 57 eggs, basket 2 has 31 eggs. You can find the sum and difference of these two numbers just to be sure, but I can tell you our answer, 57 and 31. All right, so that's the answer for this question. And hopefully now you know what are the steps to draw the bar models. All right, so let's take a breather before we move on to the next part. Okay, we are talking about logical reasoning next. Okay, so after word problems, remember word problems, read the question carefully and underline any keywords. Okay, now we are moving on to talk about logical reasoning. And one thing I want to talk about is about forming numbers using matchsticks. You see this in both of our 2023 papers. So for these type of questions, always keep in mind what is the correct way to form each digit using matchsticks and how many matchsticks are needed to form each digits. So if you are not sure, just draw them out correctly and then count the number of matchsticks. Okay, it would help if you have a digital clock and you look at it, okay, in the meantime, okay, like in your daily life, just to get prepared for these type of questions. Okay, but of course you can't bring a digital clock into the exam venue. So preparation early on is good. Okay, so the question I want to talk about today is as follows. We know how to arrange the matchsticks to form digits, and we can use this to form a 4-digit number, 2021, as shown below. Now we want to add 5 matchsticks to form a new 4-digit number. What is the largest possible value of this new number? So, couple key points in this question. First, I want to add 5 matchsticks. That means I don't touch the existing matchsticks, okay? I don't touch the existing matchsticks. And then, okay, I want to make sure I just add the matchsticks to them to make a new 4-digit number. I don't add new digits. I cannot say, oh, I put a 1 here, 1, 1, done. Cannot, all right? We need to put the matchsticks on the existing digits to turn it into as large as possible. So when we want to turn a 4-digit number as large as possible, yes, I see someone in the chat giving me the answer. Good job. Okay, if I want to turn this as large as possible, I mentioned this in one of my previous live streams. Okay, I should start from the highest digit or the highest place value. Start from my highest place value, which means I start from my thousands place 2. Okay, yes, it's 2024 now, but this question has 2021. Okay, hey. So let's take a look. Highest place value. All right, 2. I need to make it as large as possible. So let's consider 9 first. Okay, can I make 2 into a 9? Let's see, can I make 2 into a 9? Like I said, I only can add 5 matchsticks. I cannot remove matchsticks. But you see, if I want to turn 2 into a 9, I need to shift this matchstick somewhere else, right? This does not appear in a 9. But I cannot touch any existing matchsticks, so I cannot form a 9. Let's consider the next one. Okay, can I form an 8? Obviously you can, right? You just need to fill in the 2 gaps over here. Okay, so with that, we have found digit 8. Okay, that's the largest thousands digit we can have. And how many matchsticks did we use? We used 1, 2 matchsticks. Okay, it's good to take note 2 matchsticks have been used. Okay, and then let's take a look at the next digit. We can still add 3 more matchsticks, right? In total, I want to add 5. Now I've already used up 2. What about the other 3? Okay, for the other 3, let's see how we can find that. Let's consider the hundreds digits. Okay, for the hundreds digit, I have 0 over here. Then what should I do? Can I turn it into 9? Cannot. I have to turn it to 8. All right, turn it into an 8. Turn it into an 8. And then we have used up 1 matchstick. So that means 2 matchsticks are left. And let's move on to the tens digit. We have another 2. So I know from experience, I can only make it into an 8. Cannot turn it into 9. So from there, I have used 2 matchsticks again. And in total, how many matchsticks did I use? I used 2 plus 1 plus 2, which is 5 matchsticks. Okay, so 5 matchsticks have been used. So we cannot add further matchsticks to the next number. And we end up with our largest possible value, 8881. Okay, so that's our answer for this question, 8881. All right, so some of you say, hey, it's 2024. Why you give me a 2021 thing? Hey, sometimes the year is useful for the question, but it's not always the case, okay? Always pay attention to what the question wants. All right, so with that, that is on matchsticks. And now let's consider another interesting topic, which is on vertical number puzzles. So I hope that all of you now know how to do vertical addition and subtraction. But then sometimes we might be given an incomplete vertical number puzzle, like for example, 70 something minus something 7 equals to 22, for example. Okay, so this is an example. We want to fill in the numbers in the blanks. So how do we do that? Here are some tips and tricks, all right? When you have some information on the numbers, you can start from the lowest place value, okay? Something minus 7 equals to, start from that, all right? Otherwise, if there are some cases in which maybe the lowest place value doesn't give you much information, then you can start from the highest place value. For example, 1 plus star equals triangle. If I look at the lowest place here, that's too many possibilities, right? My star can be 1, triangle can be 2. Or my star can be 2, triangle can be 3. There's so many possibilities. It doesn't make sense to try one by one. So in this case, we can start looking for clues from the highest place value instead. Okay? And if you see subtraction number puzzles, try to turn it to addition because carryover is easier to handle than borrowing digits. Okay? And lastly, when you see addition, be careful for any carryover. So one classic example will be seen in this question below. We want to find out what is the value for the star, for the circle, and for the triangle. Okay, somebody already gave me the answer for the addition. Very good. Okay, how do we do this? Okay, One digit, okay, doesn't have any information useful for us. So let's consider the highest digit instead. At the highest digit I see, I have nothing plus a one-digit number suddenly become a two-digit number. Why is that the case? Is that magic? Maybe not, okay? Maybe it is because I have a carryover on top. So I have a carryover on top. So the carryover, when we add two numbers, can only be 1. So the carryover is 1. And now we have 1 plus star becomes circle, triangle. Okay, so 1 plus a one-digit number becomes a two-digit number. So what can this one-digit number be? It can only be 9, right? Because only 1 plus 9 is equal to a two-digit number 10. Even if I have 1 plus 8, for example, that is equal to 9, so it doesn't make sense. Okay, so this means my star can only be 9. Circle 1, triangle 0. I have 1 plus 9 equals 10. In fact, the whole addition becomes 1 plus 99 equals 100. Okay, so whenever you see nothing plus a one-digit number, it becomes a two-digit number. It must be a carryover doing this, okay? Must be if you have nothing plus one-digit number. As you can see in the next example, that's not a golden triangle. This is a golden triangle. Nothing plus one digit becomes two digits. Okay, this is a golden triangle. What is not a golden triangle is in this puzzle over here. So we have three shapes in this question. Each shape represents a different digit. Okay, but circles represent the same digit. Squares represent the same digits. So what digit does each shape represent? Okay, so where's the breakthrough point? Just now I said we can look at the lowest place, right? But perhaps that's not much information. Okay, so let's look at the highest place instead, okay? First of all, what do you think I can fill in with this for this? Can I fill in 2 or 3? Let's see. Two two-digit numbers add up to form a three-digit number. Then what can the hundredths digit be? Let's see. Let's say I pick my two-digit number to be as large as possible. What's the largest possible two-digit number? Isn't it 99? Okay, so let's say I have 99 plus another 99. Can anyone tell me what is 99 plus 99 real quick? 99 plus 99, what is the answer? 99 plus 99 is? Right, it is 198. Okay, 198. Okay, 198. The hundredths digit is 1. So that means regardless of what two-digit numbers there are, even if it is the largest, when I add two of these two-digit numbers together, I get a hundredths place that can only be 1. So that means my circle can only be 1. Right, and since we know this is 1, this can also be 1, and this is also 1. So my next question will be, 1 plus square equals 11. Does it mean my square is 10? Can that be the case? Cannot, because each shape only represents a digit. That means it must be a one-digit number. Okay, so that means 1 plus a one-digit number equals 11, but how is that possible? It's actually because there is a little carryover. Okay, we have a carryover at the tens place, causing it to be possible that 1 plus something becomes 11. Now that I have a carryover, 1 plus 1 plus square equals 11, which means my square must be 1 plus 1 is 2. 2 plus how many is 11? 11 minus 1 minus 1, that gives me 9. So I know my square is 9. Okay, and finally, how do we find the triangle? 19 plus 99, you can do it by now, right? It is 118. So my triangle must be equal to 8. And it makes sense, right? 9 plus 9 equals to 18, which is why there is a carryover on top. Okay, some of you say it's easy, some of you say it's hard. Okay, hopefully you know how to find the breakthrough point when you see vertical number puzzles. Okay, so yeah, this is for the logical reasoning part. All right, last but not least, I will move on to the number theory part. Okay, first we will start with odd and even numbers, which everyone finds to be easy. But I just want to remind you, whenever you see odd and even number patterns, okay, try to identify the starting point carefully. Okay, and then after finding out the starting point, list out the first few moves and then find the correct pattern. Because sometimes there are some traps, okay, hidden in such problems. So let's take a look at this problem. Hip and Bud are tossing a ball to each other. At first, Pip is holding the ball. So at the very first, before I even toss anything, Pip is holding the ball. After 79 tosses, who is holding the ball now? After I toss for 79 times, or rather, after they toss for 79 times, do you think Pip is holding the ball or Bud is holding the ball? Okay, type it in the chat box below. What is your answer? Is it A or is it B? Is it Pip or is it Bud? What do you think? Okay, some of y'all say it's easy, but I want to see how many of you fall into the trap. Okay, is it A or B? Type it in your chat below. Okay, what do you think? Is it A or is it B? Wow, I see A and B everywhere. Okay, I see that there are a good mix of some answers. Okay, a lot of A's. Wow, okay. Let's see. We want to find after each toss how many, or rather, what is the person holding the ball after each toss. So let's consider the first case. After one toss, who is holding the ball? Okay. Wow, A, B, B, B. Let's see. Pip is holding the ball before any tosses. After they toss for one time, who is holding the ball now? Is it Pip or is it Bud? Pip is holding the ball. He tossed the ball away, so that's my first toss. After my first toss, Bud is holding the ball. Before I toss, Pip is holding the ball. This at first means before I even toss, Pip is holding the ball. After that, after one toss, Bud is holding the ball. Okay? What after two tosses? Now, Pip toss to Bud, and then Bud toss again. This time, who gets the ball? Bud toss to Pip, so Pip gets the ball. Alright? How about after three tosses? So now Pip is holding the ball, and he tosses again. Okay? At the third toss, who gets the ball? Bud goes to get the ball. Okay? And how about four tosses? Okay, now tossing for the fourth time. Who is getting the ball now? Pip is getting the ball again. Okay, so I see still a lot of A, B, 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 B here. Okay, let's check what is the pattern. Okay, so if I continue, I realize that I will continue going but Pip, but Pip, but Pip. Okay, but what's the pattern over here? You see, at the first toss, third toss, and if you want to continue listing, fifth toss, these are after odd number of tosses, who will get the ball? After odd number of tosses, who gets the ball? Okay, is it Bud or is it Pip? After an odd number of tosses, Bud gets the ball. Okay, and after an even number of tosses, for example, Pip gets it at the second toss, fourth toss, sixth toss, etc. If you continue listing, after an even number of tosses, Pip gets the ball. Okay, but then let's see. We are looking at after 79 tosses. It's 79 an even or odd number? Okay, 79 is an odd number. So after an odd number of tosses, who is getting the ball? Type it in the chat below. After odd number, is it Pip or is it Bud? Okay, I see a lot of answers gradually getting more correct. And that's right, since 79 is an odd number, B is our correct answer. Bud will be holding the ball. Haha, I can see this question trapped some of you. All right, so be very careful when you see odd and even numbers in patterns. Really try to understand who is the starting point and how is the pattern like. When it's odd, who is the person that we want? Okay, because sometimes the starting point given isn't even the starting point. Okay, so this is on odd and even numbers. Be very careful when you identify the pattern. And final topic of the day is on multiples. Okay, so this is quite a common question type in people's TASMO these days. Okay, and what's a multiple? Remember what I said last week? A multiple of a whole number is the product of the whole number with any other whole number. Sounds a mouthful, right? Okay, what? Let's take a look at the example. Example, multiples of 3 include 3, 6, 9, 12, 5. So how are these multiples of 3? That's because you see 3 is 3 times 1. So 3 times 1 equals 3. I multiply 3 with 1, so 3 is a multiple of 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. Okay, so all of these numbers we get from 3 times something. So these are my multiples. Okay, and when I divide a multiple by 3, there will be no remainder. Okay, so for example, 15 divided by 3 is equal to 5. There's nothing left behind. Okay, so we can perfectly get a whole number from division. Okay, so when you see these kind of questions, again, read the question carefully for any conditions. Okay, larger than a certain number, smaller than a certain number, multiples of what number. Be very careful what the question wants. Okay, and let's take a look at this sample question over here. Among all the whole numbers larger than 50, so I'm looking for whole numbers larger than 50. All right, what is the smallest number that can be divided by both 4 and 6? Okay, I want to find among all the numbers larger than 50, what is the smallest number that is divisible or can be divided by both 4 and 6? Okay, the answer is not 18, unfortunately. All right, 4. 50 is such a large number. My multiple or my times table doesn't reach that height. So what should I do? We can start from a certain number as our starting point and then move to the front, right? So let's say the first multiple of 4 that I can think of is 40. Right, 4 times 10 is 40. That's a reasonable guess, but it's still smaller than 50. So maybe I want to find the next multiple of 4. How do I find the next multiple of 4 again? I talked about it last week. We will, do I plus or do I minus? Do I plus or do I minus? I plus, right? I plus 4. To get my next multiple, I plus 4. To get the previous multiple, I minus 4. So 40 plus 4 is 44. Still not bigger than 50. So let's add another 4 and get 48. But it's still not bigger than 50. So let's add another 4 and we can get 52. Okay, so we have 52 as our first multiple of 4 that is larger than 50. Let's proceed to list out a few more. 52, my next multiple of 4 will be 56. Okay, and then my next multiple will be, plus 4 again. Okay, 56 plus 4, 60. Next multiple, 60 plus 4, 64. All right, so I can continue listing, but maybe let's stop here for now and we look at multiples of 6 instead. Okay, so multiples of 6 that is larger than 50. Can you tell me what is a multiple of 6 that is larger than 50? It's in your times table. What is the first multiple of 6 that is larger than 50? Well, 6 1 is 6, 6 2 is 12, 6 5 is 30, still not there. 6 times 7, 6 times 8, 6 times 9. 6 times 9? What is 6 times 9? 6 times 9 is 54. So you see, we found another multiple of 6 that is larger than 50. Okay, but then, is 54 a multiple of 4? Doesn't seem like it, right? It's not in the list. So maybe we will find the next multiple of 6 by adding 6 to 54. So 54 plus 6, my next multiple of 6 is 60. And what do you notice? You notice that I have 60 as a multiple of 4, 60 as a multiple of 6. So it's both a multiple of 4 and a multiple of 6. And it's larger than 50. So I can already decide my answer is 60. Do I need to continue? No, because the question asks for the smallest number. So as soon as I find one, I can see that that is the answer. So my answer is 60. Okay, 60 is the smallest number, larger than 50, that can be divided by both 4 and 6. All right, so that is on multiples. Okay, and hopefully, okay, through this revision, you can get a better idea of these common topics that I've talked about today. Now comes the most important part. Okay, I'm going to give you some final reminders for TASMO. Okay, and believe it or not, TASMO is actually 2 days after today. It is on 31st October 2024 on a Thursday. So that day is a public holiday. Okay, 31st of October. And for P1, your competition timing will be from 1 p.m. to 2:30 p.m. The length is 90 minutes. Okay, so you will be sitting in the exam hall solving some questions. But then, even though the competition starts at 1 p.m., do remember to allocate some time, reach there beforehand to familiarize with the environment. Okay, and have some time for registration. So please report by 12:30 p.m. so that you have enough time for your registration and to find your seat in the exam hall. Okay, the exam, or rather the competition, starts at 1 sharp. So it's great to arrive early. And your location may be at top. Please location, you cannot participate in it. Okay, so please remember to come early. Okay, preferably 12:30 p.m. or even mail from our team 到电子邮件里面去查看，然后并且呢打印一份出来，到时候可以带来考场作为准考证的用途。Alright, so other than our email entry proof, please remember to bring a photo ID such as your student card, student easy link, okay, or any ID card, passport for identity verification. Okay, and remember to bring your stationeries, especially your 2B pencil. Okay, I'll talk about why later. All right, your 2B pencil, ruler, eraser, bring enough stationery for you to use. Okay, don't just bring one pencil, maybe bring a few, okay, just for standby. Okay, and finally, remember to bring your water bottle and your jacket, okay, to hydrate yourself and keep yourself warm. Okay, the venue may be cold. All right, so please remember to bring these items. And moving on, let's talk a bit about the exam format. So there will be 15 multiple choice questions in section A and 10 short answer questions in section B. The format will be similar to the 2024 sample paper. Okay, and about the marks distribution, we have 10 3-point questions, 10 4-point questions, and 5 6-point questions, totaling up to 100 marks. Okay, if you have any questions that you did not answer or you answered wrongly, not to worry, there will not be any points deducted. Okay, but if you get it correct, of course, you will get the full marks. Please shade it completely. On the right, which is given, let me see, then write C here. Okay, or shade it completely. Don't shade it halfway. Don't give me a shade completely. Don't shade it halfway. Don't give me a shade. Shade it completely. And for short answer questions, if you think the answer is 123, just write it clearly within the box. All right. So please make sure your answers are written neatly for the examiner to understand what you are writing so that they can award you as much marks as possible. Okay, so with that, that is the end of today's live stream. Okay, we will be having our competition 2 days later. So I wish everyone all the best. Okay, hopefully luck is on your side in this Thursday's competition. Okay, I will see you in TASMO. Okay, and with that, thank you for your participation today. All right, so yeah, please have a restful evening. Okay, so that's the end. 检查填写的部分，我们监考老师会尽力的填写。当然呢，就是趁现在还有2天的准备时间，可以花一点时间给孩子练习一下，要怎么样去运用那张答题卡的。对，毕竟是以后的竞赛也都会使用到的，所以这一点也就对，需要跟进一下。Okay, if you have any questions, feel free to let me know, okay, in this live stream or to type it in the group chat below, okay, and I will share the complete solutions later. All right, goodbye, everybody. All right, so all the best for TASMO. All right.